Hey everyone, welcome back. Today we're embarking on an extensive journey into cloud engineering. If you've been curious about how the backbone of modern computing operates, you're about to get an in-depth look. Let's dive in. So what is cloud engineering really? It's not just about moving data to the cloud. It's an intricate dance of strategy, architecture, and continuous improvement. It's the art and science of leveraging cloud computing technologies to create scalable, secure, and efficient systems. Imagine not just having servers, but orchestrating a symphony of services that can dynamically respond to demand, optimize costs, and ensure data integrity. Let's talk about a couple of these topics here. So one is scalability. One of the most transformative aspects of cloud engineering is its ability to scale, whether it's handling the sudden spike from a viral product launch or managing the steady growth of an enterprise. Cloud resources can be scaled up or down almost instantaneously without the need for physical hardware. Another important aspect is the cost efficiency. The pay-as-you-go model of cloud services means businesses can avoid the sunk cost of idle hardware. Cost optimization becomes an ongoing strategy where engineers use tools like AWS Cost Explorer or Azure Cost Management to ensure every dollar spent is justified. And then we have flexibility. This goes beyond just location independence. In cloud engineering, you can experiment with different configurations, deploy applications in minutes, and pivot strategies without the traditional constraints of hardware procurement and setup. Now let's go into a deep dive into cloud components and break down the layers of cloud services. So one is infrastructure as a service. At the base, IaaS provides the raw materials, virtual servers, storage, and networks. It's like renting land where you can build your house. Examples include AWS EC2, Azure Virtual Machines, and Google Compute Engine. Here, you're responsible for managing the OS, applications, and data, but not the physical hardware. Then we have PaaS, Platform as a Service. This layer offers an environment for developers to build, test, and deploy applications. Think of it as a furnished home where you can move in your furniture. PaaS handles the complexities of network, storage, and server management. Services like Google App Engine, Heroku, and Azure App Services fall into this category. Then we have SaaS, Software as a Service. This is where most users interact with the cloud. It's the fully furnished, ready-to-live-in apartment. Examples are Gmail, Salesforce, or Dropbox. Here, the cloud provider manages everything from the application to the infrastructure beneath it. Then we have security. In cloud engineering, security is paramount. It involves a multi-layered approach. One is encryption. The data in transit and at rest should be encrypted. Another is identity and access management, IAM, ensuring only authorized users access specific resources. Then we have compliance, adhering to standards like GDPR, HIPAA, or PCI DSS, depending on the industry. Then we have network security, using firewalls, security groups, and virtual private clouds, VPCs. Now I wanted to bring you through a day in the life of a cloud engineer. This is just to give you an idea of what the on-the-job aspect of things might look like. So in the morning, you could be monitoring dashboards like AWS CloudWatch or Azure Monitor to check system health, performance metrics, and security alerts. Maybe you're running through a checklist of daily maintenance tasks or preparing for an upcoming system upgrade. Then mid-morning, maybe diving into architecture design or refactoring an existing cloud setup for efficiency. This could involve using tools like Terraform for infrastructure as code, ensuring that deployments are repeatable and consistent. And then at lunch, often a learning opportunity, whether it's catching up on new AWS announcements, reading about serverless architectures, or pursuing certifications like AWS Certified Solutions Architect or Google Cloud Professional Cloud Architect. Then in the afternoon, you might be tackling an incident. Perhaps a database is experiencing latency. You diagnose, perhaps scale the database or optimize queries, or you might be working on automating deployments with CI/CD pipelines using tools like Jenkins, GitLab CI, or GitHub Actions. In the evening, you're reflecting on the day, planning for future projects, or contributing to open source cloud tools. The cloud never sleeps, so there's always something to monitor or improve. Now let's talk about why cloud engineering is the future. One is you have the Internet of Things, IoT, with billions of devices connecting. Cloud platforms are essential for data aggregation and analytics and management. Two is we have AI and machine learning. These fields require massive computational power and data storage, which cloud services provide on demand. Three, we have edge computing. Cloud engineering now extends to the edge, reducing latency for real-time applications by processing data closer to where it's generated. Then we have sustainability. Cloud providers are increasingly focused on green computing using renewable energy resources, meaning your cloud strategy can also be an environmental one. So we've journeyed through the clouds today, exploring what makes cloud engineering a cornerstone of modern technology. If you are intrigued by this field, remember the sky is the limit. Like, subscribe, and don't forget to hit that bell for more insights into the tech world. Until next time, keep your heads in the clouds, but your feet on the ground with practical, impactful cloud engineering.